Good morning, fellow mathematicians. Welcome back to another video. In today's video, we are going to talk about this guy right here, the integral of 1 over x to the third power plus 1. If you don't know anything about some techniques I'm going to use, just take a look into this. In the description there will be links to the corresponding videos. Okay, so this is going to take a little bit longer, but it's quite simple. It's really quite simple of an integral. Okay, so at first we are going to factor the denominator. Okay, so this whole thing is equal to the integral of dx over x plus 1 times x squared minus x plus 1. Okay, and as you might notice, this denominator looks absolutely awful. So we are going to use partial fraction decomposition to split this into more fractions to make it a little bit easier to integrate. So let's look at some partial fraction decomposition. Okay, so let's take a look at 1 over x plus 1 times x squared minus x plus 1. Okay, and this is equal to, as you might see, we got two factors here, so in the end we want to end up with the sum of two new fractions. So this is equal to blah over x plus 1 plus blah over x squared minus x plus 1. Okay, the first one. So this has degree 1 in the denominator, so our numerator has to have degree 0. So let's just call this a. Okay, this denominator has degree of 2, so we need a degree of 1 in the numerator. So let's call this bx plus c. Okay, and now we are going to multiply both sides by this great denominator right here. Okay, so what we end up with at first is just that 1 equals 2. Okay, so x plus 1 would cancel out on this, so this is just ax squared minus ax plus a. Okay, and the next one. This and that would cancel out, so that's bx plus c times x plus 1. So let me write it this way at first, bx plus c times x plus 1. And now we can distribute all of this stuff. So in the end, this is equal to ax squared minus ax plus a plus, okay, so that's bx squared plus bx plus cx plus c. Okay. The first little observation. The polynomial on the left has a degree of 0. So in order for those two sides to be equal, this polynomial has to have a degree of 0 too. So we need to get rid of everything that's higher than degree 0. So we need to get rid of those x squared and x terms. Okay, so we got two x squared terms right here. So those have to equal to 0. So ax squared plus bx squared have to equal to 0. So this cancels out, and we can conclude that a is equal to minus b, or equivalently b is equal to minus a. And now we can plug this new information in. So this means that 1 is equal to this, and that cancels out. Okay, so that's just minus ax plus a. We now know that our b is just minus a, so that's minus ax plus cx plus c. Okay, we can bring those two together. So this is just minus 2 ax plus a plus cx plus c. Okay, next observation. We need those two terms to equal to 0 because they have a degree of 1. So our next conclusion is, let's write it here, that minus 2 ax plus cx have to equal to 0. So those x's would cancel out, and we end up with that c is equal to 2a. And we can plug this new information in. Okay, so in the end, 1 is equal to, okay, this cancels out and this cancels out. That was our observation right now. So this is just a plus, and c equals to 2a. So this is just 2a, and this is equal to 3a. Okay, and that would mean, if we divide this whole expression by 3, that a is equal to 1/3. Okay, we can plug this condition into c, for example. That would mean that c is equal to 2/3. And that would also mean we know that a is equal to minus b. So b is equal to minus 1/3. And that was our partial fraction decomposition. And now we can plug all of this new information into our integral right here. Okay, so this is equal to the integral of, okay, at first we got 1/3 over x plus 1 times dx. The integral is linear, so we can split it up. Plus, okay, let's bring this 1/3 to the outside. So that's 1/3 times the integral of x minus x, because it's minus 1 over 3, minus x plus 2 over x squared minus x plus 1 times dx. Okay, we could also bring this minus to the outside. Let's do this. So we can change the sign right here, and yeah, we can do that. Okay, so this first integral is kind of easy. That's just 1/3 times the natural log of x plus 1. So our first conclusion is that this is equal to the 1/3 times the natural log of x plus 1 plus, no, we got a minus now, minus 1/3 times the integral of x minus 2 over x squared minus x plus 1 times dx. Okay, right now this denominator looks not so good. So we want to substitute this. What we could do, we could complete the square on this one. So let's complete the square on x squared minus x plus 1. When we do that, we end up with x minus 1/2 squared, and then plus 1 minus 1 over 4. Okay, so we can bring this together. So in the end, that's just x minus 1/2 squared plus 3/4. Okay, and now we can plug this new information in. So this is equal to 1/3 times the natural log of x plus 1 minus 1/3 times the integral of x minus 2 over x minus 1/2 squared plus 3 over 4 times dx. And this chalkboard is sliding up all the time. It's kind of annoying. Okay. We want to split this integral up a bit, so let's just take a look at this integral right now. Once again, we can use the linearity of the integral on this one. So this is just the integral of x over x minus 1/2 squared plus 3 over 4 times dx minus 2 over x minus 1/2 squared plus 3 over 4 times dx. And now we are going to solve for this one at first, because that's the easier one. We are going to introduce a new substitution. Let's call it u. Okay, so let u equal to this right here, x minus 1/2. That would mean, if we differentiate that du equals to dx. Okay, so we can plug this in. Let's look at this one first. So minus 2 times the integral of du over u squared plus 3 over 4. Okay, now we are going to transform this 3/4 a bit. So this is the same as the square root of 3/4, but squared. And as you might notice, we can use a certain identity on this integral, and we are going to end up with the inverse tangent, kind of. So this is equal to minus 2 times, okay, now it's the square root of 4 over 3 times the inverse tangent of u over the square root of 3 over 4. Okay, so we have solved the first one. Now we have to solve for this one right here. Okay, so we can also use the same substitution. Let's just call it v right now. Okay, so let sum v equal to x minus 1/2. That would mean that dv is equal to dx. But as you might see, we've got an x right here in the numerator, so we have to isolate our x somehow. You will also see that x is equal to v plus 1/2. So when we plug this in, we are just looking at this integral right now. So that would mean that the integral of x over x minus 1/2 squared plus 3 over 4 dx is equal to, okay, so this is just the integral of v plus 1/2 over, okay, now we plug in our v, so that's v squared plus 3 over 4 times dv. Okay, next step, we are going to split this integral up again. So let me write this out. So this is the integral of v over v squared plus 3 over 4 times dv plus, I have to write it here, I'm sorry, I'm out of space, plus the integral of 1/2 over v squared plus 3 over 4 times dv. And once again, this guy right here is just the arctangent. So if we transform this a bit, so that's the square root of 3 over 4, but squared, then that would mean that this guy is just 1/2 times, okay, so this is the root of 4 over 3 times the inverse tangent of v over square root of 3 over 4. Okay, and now we only have to solve for this one right here. And it's not quite hard. We are going to introduce substitution once again. So let's see what this is. So the integral of v over v squared plus 3 over 4 times dv. Let's introduce a new parameter, w. Okay, so let w equal to v squared plus 3 over 4. That would mean that dw equals to 2 times v times dv. Okay, now we can multiply everything by 1/2 on both sides, so this expression right here is just equal to 1/2 times dv. So this integral is just 1/2 times dw, dw not dv, I'm sorry, dw over w, and this is just 1/2 times the natural log of w. Okay, and now we can plug all of the stuff we found out into our original equation, and then we will substitute back, and yeah, stay tuned. I wrote out all the expressions now, so this is our expression, but with our substituted variables right now. Okay, so let's expand this at first. Okay, so this is equal to del n of x plus 1 over 3 plus, so this is 2/3, and then that's the square root of 4 over 3, so that's 2 over the square root of 3. So that's 2 over square root of 3. So all in all, this makes just 4 over 3 times square root of 3 times the inverse tangent of. So what is u? u equals to x minus 1/2. So that's x minus 1/2 over, okay, this is the square root of 3 over 4, so that's the square root of 3 over 2. We can bring this 2 up, so that's 2 times this expression over square root of 3. This was the first one. Okay, so now the second one, so that's minus 1 over 6. Okay, times the square root of. Okay, so at first that's 2 over the square root of 3, and we can bring this together, so that's 2 over 6 times the square root of 3. Okay, times the inverse tangent of v equals to x minus 1/2. So this is x minus 1/2, and once again it's 2 times this expression over square root of 3. And in the end, plus 1/2 times 1/3, so that's minus 1 over 6, del n of w. But w is just v squared plus 3 over 4. But v squared is just this expression squared. And this was just our answer that we've got for completing the square. So this is just del n of x squared minus x plus 1, plus some arbitrary constant c. And now we can bring all of this stuff a little bit together, because we can cancel out this 2 right here. So this is just 1 over 3 times the square root of 3. And those two terms are the same right here, so we can subtract them. So in the end we get, this is del n of x plus 1 over 3 plus 3 over 3 times the square root of 3. So those 3's cancel out, so that's 1 over square root of 3 times the inverse tangent of, and this is just 2x minus 1 over square root of 3. And in the end, minus 1 over 6 del n of x squared minus x plus 1 plus some arbitrary constant c, and then we are done. Okay. Those are kind of messy and I'm improvising them, so I have no idea what the answer is, so I hope it's correct. If it isn't, I have to record this video once again. But if you like this video, please like and subscribe and leave some comments and recommend me if you like. And see you in the next video. Have a nice day. Goodbye.